to rewrite different trig functions into things that are more palatable, easier to work with. So we're going to be doing a lot of converting something that looks like this to something that looks like easier to solve, easier to put into our unit circle. But we won't be using the unit circle for at least a little bit now. So the first couple identities we've already talked about are reciprocal identities. And that is sine is equal to 1 over cosecant. So anytime you see sine, you can rewrite it as 1 over cosecant or vice versa. Cosine is 1 over secant. Tangent is 1 over cotangent. And then we can just go the opposite direction. If I see cosecant, I need to write it in terms of sine. I can rewrite it as 1 over sine. Secant can be 1 over cosine, and cotangent can be 1 over tan x. Then we have something called the quotient identities. The quotient identities only deal with tangent and cotangent. That is that tangent can be rewritten as sine over cosine. I don't know what's happening. And cotangent can be written as cosine over sine. Odd-even identities, we'll talk more about that on Tuesday because we don't have class on Monday. But those are just ways to rewrite if you have a negative sign inside of the parentheses. The big thing with odd-even function, the only one that you can make the negative sign go away are cosine and secant. If you have a negative inside there, you can just get rid of it, and we'll talk more about that on Tuesday, why you can do that and why you can bring it out in front of all the other ones. See all these things here? Those are based upon one thing, and that is your sine squared plus cosine squared equals 1. All of those come from that one statement. All of those come from that one statement. And in fact, all of these variations are just moving numbers around. So if you have sine squared plus cosine squared equals 1, you can subtract cosine squared from both sides and have that first variant. So these aren't all things you need to memorize. These are just showing you can move numbers around to match what's given to you, and you'll see what I mean when we do different identities. And we'll talk about where these come from. So if you know sine squared plus cosine squared equals 1, you really don't have to memorize anything else. All of this comes from just that one statement. I will also print out a card that has all these on there for you, so you don't have to always go back to this page. That will be coming, and then we'll have a big identity sheet also. All right, Pythagorean identities. Like I said, all of those Pythagorean identities come from the one sine squared plus cosine squared equals 1. Once again, you don't have to memorize. You just need to know sine squared plus cosine squared equals 1. The first thing we're going to do is we're going to divide sine squared plus cosine squared equals 1 by just sine squared. So that means we're going to divide both sides by sine squared. So all we're going to do, divide this side by sine squared alpha, and divide that 1 by sine squared alpha. Well, when I distribute all this out, we are going to have sine squared alpha divided by sine squared alpha plus cosine squared alpha over sine squared alpha is going to equal 1 over sine squared alpha. Well, anything over itself is just 1. So sine squared over sine squared is just going to be 1. Well, cosine squared over sine squared, we can rewrite that. That is the first time we're going to change something using our identities. So if I go back to my identity sheet, what I'm looking for is something that has cosine over sine. Well, that's cotangent. Cotangent is cosine over sine. Well, this is cosine squared over sine squared. But remember, this is really just cosine times cosine over sine times sine. So we can change that into cotangent times cotangent, or just cotangent squared. Since the squared on top matches the squared on bottom, I can replace the whole thing with cotangent squared. I can replace the whole thing with cotangent squared. Our next thing is 1 over sine squared. So I'm going to go to my identities and look for something that says 1 over sine. Well, that's cosecant. 1 over sine squared is just going to be cosecant squared alpha. That's just that identity. All right, I just needed to divide both sides by sine squared, and I get that third identity. To get that second one, we're just going to divide everything by cosine squared. So we're going to divide everything by cosine squared, which is going to give me sine squared alpha divided by cosine squared alpha. Then we're going to add cosine squared alpha, and we're dividing that by cosine squared alpha, and that's going to equal 1 over cosine squared alpha. Well, simplify this. We have sine over cosine. If you look at our identities, tangent equals sine over cosine. But since it's sine squared over cosine squared, we're just going to replace that with tangent squared. Then we have cosine squared over cosine squared, which is just 1. And that's going to equal 1 over cosine squared. Well, 1 over cosine is the same thing as secant. If you look at the top sheet, that is just your secant. So that's just going to become secant squared alpha. And that is that second Pythagorean identity. Now, while we're on this really quick, I do want to say you're responsible to know everything in here. So I can give you just this sheet and it being blank, and you have to be able to fill everything in. Not completely blank. I'll put like sine x equals, and you have to put something. And I'll put cosine x equals, and you have to put some blank here. On this quiz, if it hypothetically happens, you don't have to put all the variations. You just have to put these 3. These are the only 3 you need to know to fill in that box. All right, just these 3. You would need to know this, and after Tuesday, you will have to know this, because on Tuesday is when we actually talk about the odd-even functions. These you should already know. They're just reciprocals. We've already done those. These you should kind of know, because we talked about what tan x and cotangent x equals. These all stem from sine squared plus cosine squared equals 1. So most of this you should already have memorized. It shouldn't be this big thing you have to memorize this whole thing. It should be pretty easy, unless you haven't done any of it and you didn't know sine squared plus cosine squared equals 1, which I hope you did. But you have to have that whole thing memorized or know how to at least attain it. Me personally, I don't always have these memorized, but I just know divide this by sine squared and I get one of them, divide it by cosine squared and I get the other one. And I can develop both of those. So don't forget about these 2 things. I do think it's important that you can, in your head, you can go, okay, divide both sides by sine squared, divide both sides by cosine squared. I have the other 2. They aren't things I need to have memorized. All right. We're going to start talking about simplifying the easiest of our identities. These get harder and harder. These are the easiest because they tell you what to do. These say write each expression in terms of sines and or cosines. Then they say simplify. So your first thing is to take everything that's written there and change it to terms that are sine and cosine. So right now we have tangent and secant. Neither of those are in terms of sine or cosine, so we need to replace both of those. So the first one we're going to replace is that tangent on top. You just go back to your identity sheet, and you say, well, I can rewrite tangent as sine x over cosine x. So that's exactly what you're going to do. You're going to come back here and rewrite your top as sine x over cosine x divided by, now we're going to replace secant. Well, if you go back to that identity sheet on the other side, you're going to see that secant equals 1 over cosine. secant and cosine are joined at the hip, just like sine and cosecant are joined at the hip, just like tangent and cotangent are joined at the hip. So I'm going to rewrite secant as 1 over cosine. Now I'm going to use keep, change, flip. Keep the top fraction, so we have sine x over cosine x. Change your sign to multiplication and flip whatever's on the bottom. So right now I have 1 over cosine x, so we'll have it as cosine x over 1. Your cosines are going to cancel out. You're going to have sine x equals 1, and you're just going to be left with sine x. I believe last year I put this on the test and a whole bunch of people got it wrong because it looked too easy. All right, just follow the directions. Don't make your life really hard. That's all you're supposed to do is write each expression in terms of sine and cosine and simplify your way down. All right, let's go ahead and go do b here. Well, b, we already have sine x, so I'm going to leave it as sine x. We already have cosine x, so we're going to leave that there. The only thing we need to change, where's my highlighter? The only thing we need to change is that cotangent x. That's the only one that's not written in terms of sine or cosine. So we're going to have sine of x plus, can someone tell me what I could rewrite cotangent as if I want to write it in sine and cosine? Can you? Cosine of x over sine of x. Tangent and cosine can be the hardest to remember. Because tangent can be rewritten as sine over cosine, and cotangent can be written as cosine over sine. Kind of how I remember that order: cotangent, cosine first. Cotangent, cosine on top. All right, so I always think about cotangent before I think about tangent. Tangent, sine on top. Cotangent is cosine on top. You need to know that. You need to keep those two straight because it's easy to flip those two. So I just always go cotangent, cosine's on top, and then I know what tangent is because tangent must be sine on top. All right, so now we're multiplying this by cosine squared x. Not cosine squared x. I'm just going ahead of myself right now. It'll just be cosine x. This one's going to be a little bit tougher than the other one because right now we have cosine squared on top. So this is going to equal sine of x plus cosine squared x over sine of x. This gets into one of our first tricks when simplifying identities. It is pushing two things together. This doesn't look simplifiable as it is. So one of your tricks you're going to do is you're actually push those two things together. In order to push these two things together, you need to have a common denominator. And we need to use sine as our denominator. Right now, this is sine over 1. Right now, this is sine over 1. What was that?
1.
Yeah, 1.
Wait,
Wait,
what?
what? I thought you were just agreeing with me. Yeah, sine of x over 1. So right now, our denominators are not the same. To make them the same, we would like this to be sine of x. Well, we can multiply that by sine of x as long as I multiply the top by sine of x. As long as I multiply the top and bottom by the same thing, we are okay. So we're going to multiply the top by sine of x, and we'll multiply the bottom by sine as well. A lot of times I'll shortcut by not writing the x all the time. All right, right here I don't have a ton of space, so I'm just going sine, as long as you keep track that it's sine of x. Yes?
So would you have to multiply sine to the cosine squared over sine as well, or is it just...
Nope, because what's sine over sine equal? So I'm multiplying this by 1. Do I need to multiply both by 1? No, I don't. There are problems where you do have to multiply it all the way through to make it work. But in this case, I'm multiplying by 1, so I'm allowed to do that on any one that I want to, as long as I'm not adding pi, adding 1 or something. I'm multiplying by 1, so I am okay here. And people that didn't get that, you might want to write that note down that you are multiplying by 1. That's what allows you to do that. You need to know why you can do certain things. So that's going to give us sine squared x over sine of x plus cosine squared x all over sine of x. Whole goal was to create a common denominator, so I can now push those two things together. When you have a common denominator, you add your numerators. I'm going to run out a little bit of space, so I'm going to go doot, 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 doot. Put it right there. I'm going to have that equal sine squared x plus cosine squared x all over sine of x. This is a big thing that's going to show up over and over and over and over and over and over again. This is going to be one of those things that you have to just look at and know what it equals, and eventually you will. This is our Pythagorean theorem. Sine squared plus cosine squared equals 1. That goes back to just this statement. Anytime you see sine squared plus cosine squared, in fact, anytime you see a sine squared or a cosine squared, you need to think of this equation. In fact, anytime you see anything squared, tangent squared, secant squared, you're going to have to think about one of these every single time to rewrite it. So right now we have sine squared plus cosine squared equals 1. So we're going to replace that entire top fraction because this whole thing equals 1. Sine squared plus cosine squared equals 1. So you're allowed to replace 1 for sine squared over cosine squared. So that's sine of x. And 1 over sine of x is just cosecant x. And so we could write this whole thing as just cosecant x. Now if I had a value, I could find it on the unit circle. So in this case, if it was, sine of 3 pi over 4, cotangent of 3 pi over 4, cosine of 3 pi over 4, I just really had to find cosecant of 3 pi over 4, and I have my answer. Yeah?
Let's say if it was a number, I still have the same number, right?
Yes, for the most part.
For the most part?
Yeah.
If they're not the same number, are you allowed to do it?
No. And we'll do problems like that. We'll have like an alpha and a beta where we have to kind of treat it separately. Yep. But right now we don't have to worry about that. That's future problems. That's a future lived problem, not today. Way to think ahead, though. All right, so we reduced that all the way down to cosecant x. All right, we just have one more to do. We got a fraction here. Like I said, don't try to get ahead of yourself. Just change stuff to sine and cosine and see what happens from there. So we have tangent x, cosecant x, and secant x that I need to replace. Let's replace that tangent x. Well, I can replace that tangent x. Cotangent's cosine on top, so tangent must be sine on top. So we'll have sine of x over cosine of x times cosecant is 1 over sine. And this will be all over whatever secant is. Well, secant is 1 over cosine. Let's tackle the numerator first. Let's do all this multiplication before I try doing keep, change, flip. There are other ways you can do it, but I'm just going to do it that way. I'm going to come down here. Our sines will cancel out, and we'll be left with 1 over cosine all over 1 over cosine x. Two ways you could tackle this. 1 over cosine is just secant. So you could replace this with secant over secant, or you could just recognize I have the same thing on top as I do on bottom, so that's just going to equal 1. All right, once again, you could rewrite this, and maybe I will, just so we can do one extra step. We could rewrite this as secant x over secant x, which equals 1. Or you could have just stopped here and said it's the same thing on top of the same thing. It just equals 1. I don't have to go any further than that. So surprisingly enough, this one looks like the more complicated one because it's already a big fraction. Turned out it was pretty easy. This one looked like it was going to be easy because it's just like a straight addition thing, and it turned out to be the most complicated one. So don't just look at it and say it's going to be complicated, this is going to be easy. Just start working on it, and honestly, just follow your nose on these. Just plug stuff in and work. The worst thing you can do on these problems is just quit. Quit doing something and just stare at it for 5 minutes. Do something. Try something. Don't try to think 5 steps down the road. Just, like I said, if you have 2 things apart, combine them, see what happens. We'll learn other tricks we can use, but just try something, and if it doesn't work, you should have all pencils and erasers. You just erase it, or you say, Mr. Fabian, can I get a new sheet? I marked this one up too much. Anything like that, just try stuff on all of these. All right, questions for me? All right, the rest is homework. These are all pretty not bad ones. The backside ones are a little more difficult. And then real quick, on the one with all the letters on the back on page 78, I believe, you can use the letters more than once. In fact, there's not enough letters that match up with the numbers you would have had to even use them all. So you can use some more than once. All right, as always, answer keys posted.